Okay, here's a second example. We're actually going to use our quadratic regression to find the answers for this one. First, look at the situation. I've slightly altered this to make it a little bit more usable. It says a young boy is trying out different paper airplanes. Let's draw a little picture. So we have a boy throwing paper airplanes. You throw a paper airplane, it kind of goes up and then falls down. It says one particular trial, he released the plane at 5 feet. So this height right here is going to be 5 feet. So there's my release. So that's going to be 0 seconds. And he said again after 2 seconds, it was at 5 feet again. So this time has to be 2 seconds. So it went from 5, went up, and then came back down to 5. Plane reaches, and we're not going to say it's the highest point, because it really wouldn't work. And then landed after a total of 5 seconds. So 5 seconds it was on the ground. So let's list out these points, because we're going to need 3 points to do a quadratic regression. If you don't have 3 points, it won't work. So this point right here, 0 seconds, it was 5 feet in the air. This point right here, after 2 seconds, it was 5 feet in the air. And the last point here, after 5 seconds, it was 0 feet in the air. Now I'm going to make a table for this because it's so much easier looking at that in the table. So I'm going to say X and Y. My X is my seconds, 0, 5. My Y is my distance from the ground, 2, 5. And 5, 0. Lots of 5s there. Now let's do a quadratic regression. So we want to find the equation for this. Find the equation for that. So we're going to do quadratic regression. So what I want to do is, let's go to that stat plot. Let's edit it up. And we're going to go clear there, go up, clear there, and we have them cleared out. We're now going to put these in. So we have 0 inner, 2 inner, 5 inner. Go over to the other one, 5 inner, 5 inner, 0 inner. With all of that in my calculator, I can go ahead and do my regression. So I can do stat over quadratic regression. And I'm going to go ahead and store that into my calculator already. So I go here to the store, tap vars, go to the right for y bars, and then I want my functions, and I want to put it in y1. Now you could choose the other ones that would go in there, but we're going to usually keep everything in y1. There it is. There are my numbers there. Let's talk about those numbers. These numbers are a little different than we normally see. This is a repeating fraction. It's a negative number. What repeating fraction would be 0.333 repeating? That would be 1/3. So it's negative 1/3. B is 0.666666 repeating on forever. That's 2/3. And then C is just simply 5. So my equation here for this, I guess right here, is going to be y equals negative 1/3 x squared plus 2/3 x plus 5. Okay. And let's just look at the table. You can see in the table here, and start at 0 so we can see that. So at 0, he throws that 5 feet. He throws that 5 feet at 0. After a second, it goes all the way up. Looks like it's going to be the maximum at 5 1/3 feet. And then it starts coming down, and it's going to hit the ground back again at 5 seconds. 5 seconds, hits the ground again. So there's the situation there. We go ahead, we can actually look at the graph of this. It's set up for our last one. Or maybe not. Let's do a zoom stat, see if it changes it much. There we go. So there's where the person throws it from, goes up, hits that 5 feet again, and then comes and hits the ground. Very similar to what we drew over here. Okay, then it says, what would the equation be if a boy climbed up a tree and released a plane from a height of 12 feet? So what's changing in all this? We're just going to be changing where we started. So instead of this being 5 feet, this would be 0, 12, which would mean that would be 2, 12, and this would be 5, 7. Well, this is not where it hits 0 anymore. It's going to keep going. Everything's up raised 7. 5 to 12 is 7. 5 plus 12 is 5 plus 7 is 12. So my new table will be 0, 12, 2, 12, and 5, 7. And we can do a whole other quadratic regression and use those points to do a quadratic regression. Or we can just remember, this is my y-intercept. All I have to do is change that part. Negative 1/3 x squared plus 2/3 x. And that's where I start. So instead of starting at 5 feet above the ground, I'm just going to change that to plus 12. And that's the only change I need to make. In my calculator, I can tap in there, and I can just scroll over to this, and it says, well, here's 4.999. Just delete all that, and I can just tap in 12. Enter. Now I can look at my graph. And I'm probably going to have to zoom out. Well, I didn't fix the points, so let me zoom out. There we go. So that's what it's going to look like. Everything's just raised up a little bit. Alright, what's the maximum height of the plane? I'm going to go ahead and look at the table for that. Maximum height here is going to be 12 1/3. 12.3 repeating, or 12 1/3, however you're going to write that. Domain of the situation. Well, I told you the domain's going to go from 0, and now we need to figure out when it's going to hit the ground. Oh. It hits the ground somewhere between 7 and 8. It looks like it's pretty close to 7. If I go to my graph, I can actually calculate what that's going to be. Just as a reminder, we learned this in 8th grade and Algebra 1. To find this point over here, and it's going to be somewhere close to 7, I can do this calculate function up here. So I press blue calculate, and I'm going to go down to find where they intersect the ground. So I'll move the little spider ball thing all the way over here, close to it, and then there's no other second. Oh, I don't want intersection. I'm sorry. Not intersection. I need the 0. 0 is where they cross the x-axis. Intersections where two meet. 0. So, left bound, right bound. Once to the left, once to the right. Don't need to hear about your guess. Just press enter again. My 0 is at 7.0827, whatever. So this would be 7.08. Let's just call it that. And my range, 0 to, what did we say it was maximum? 12 1/3. And real life situations, again, will usually have zeros at their domain and range beginnings. And of course they differ for the function because they start and end at some point.